In this video, I'm going to go over the hyperbola. The horizontal hyperbola opens to the left and to the right. The equation can be written as x minus h squared over a squared minus y minus k squared over b squared is equal to 1. The vertical hyperbola opens upwards and downwards. The equation is essentially the same, with y minus k squared over a squared minus x minus h squared over b squared is equal to 1, with the only difference being that the x squared term and the y squared term are switched. In either case, the center is at h, k. To draw the hyperbola, it's good to look at the center area, which we draw as a box. So from the center, for the horizontal one, from the center over to the right side vertex is a distance a. From the center up to the top of the box is b. And keep in mind that the foci are on the outside. Then the vertices are located at h minus ak and h plus ak. So essentially adding and subtracting a from the center, x value. The foci are located at h minus c, k and h plus c, k. So same idea, it's from the center you add c and subtract c from the x value. And finally, the asymptotes can be written as y minus k is equal to plus minus b over a x minus h. And the asymptotes are used to determine the shape of the hyperbola, essentially how wide it opens. And the main thing to keep in mind with the asymptotes is that you're using rise over run to create a linear slope. So for the horizontal one, the rise is b and the run is a, so that's why the slope is written as b over a. If we look at the center of the vertical hyperbola, notice that the a and b values switch. A is now the distance from the center up. In this case, it's to the vertex, since for a vertical hyperbola, the vertices are located above and below the center. So that's the value of a, and b is the distance from the center over to the right and left. The formula for the vertices are h, k minus a, h, k plus a. And for the foci, the same thing with c. So in this case, notice that we're affecting the y values. So for the vertices, we're adding and subtracting a from the y value of the center. And for the foci, we're adding and subtracting c from the y value of the center as well. The equation for the asymptotes is essentially the same. The only difference is that the slope now becomes a over b. That's because in this case our rise is a and our run is b when we find those two linear equations. Now I want to talk a little bit about using the equation a squared plus b squared is equal to c squared when working with a hyperbola. And before I talk about the hyperbola, I want to talk about the ellipse. So if we recall, there's the center of the ellipse, two foci, and two vertices. And in that case, the distance from the center to the foci is c, which is the same as for the hyperbola. I'm just looking at a horizontal ellipse in this case. So from the center up is b, so the only value left is our a value. So that's the longest distance, and that's the hypotenuse of our right triangle. And so for that reason, we use b squared plus c squared is equal to a squared. And that's because anytime we're using the Pythagorean Theorem, the two values that we're adding together have to be the two shorter distances. Now if we look at the hyperbola, the main difference here is that the foci are on the outside of the vertices. So if we go ahead and complete our right triangle, b in either case is the distance from the center up, but the other leg of the triangle is a, and that's the distance from the center to one of the vertices. And that means the value that's left is the value of c. And c is the longest in this case because the foci are on the outside of the vertices. So for that reason, when we're working with a hyperbola, we would do a squared plus b squared is equal to c squared. Now let's look at this example. And I hadn't mentioned this before, but just to mention it now, the difference in the equations from an ellipse to a hyperbola is just that subtraction is used. So first I'd notice that since the y value comes first, that means we're going to be dealing with a vertical hyperbola that opens upwards and downwards. And also a is the square root of 256, which is 16, and I can find that b is equal to 12. And before I do anything else, I might just go ahead and find the value for c using the Pythagorean Theorem. So a squared plus b squared is equal to c squared. And solving that out, we get that c is equal to 20. Now let's say for this example we want to first find the center, the vertices, the foci, and then the asymptotes. To find the center, we use the y plus 1 and x minus 5 to get 5 comma negative 1. To find the vertices, we use the center and we use the value of a. So we add a and subtract a from the y values of the center. So that gives us 5 comma and then negative 1 minus 16, and then 5 comma negative 1 plus 16. Same idea for the foci, but in this case we're adding and subtracting c from the y value of the center. So c is 20, so that gives us 5 and then negative 1 minus 20. The other point is at 5, negative 1 plus 20. And finally, let's use the equation for the asymptotes, which is y minus k is equal to plus minus a over b times x minus h. So remember, a is 16 and b is 12. And then if we plug in our two values for the center, we get y plus 1 is equal to plus minus 16 over 12 times x minus 5. And the only thing I'm going to do to simplify the asymptotes is to just simplify our slope. So if we do that, we get y plus 1 is equal to plus minus 4 over 3 times x minus 5. The reason I'm not going to simplify it further, this is giving me the equation for two linear equations. The y plus 1 and x minus 5 means I can kind of treat it as though the center is going to be at 5 comma negative 1, which is the center of the hyperbola. And then from there I can draw my lines by just using a slope of plus 4/3 to get one of the asymptotes, and then negative 4/3 to get the other asymptote. And now to finish this problem, let's graph the hyperbola. So here's everything that we had found on the previous slide. Let's start by plotting the center at 5 comma negative 1, plot the vertices, plot the foci. So notice that the foci are on the outside of the vertices. Now I'm going to use the value of b to find the endpoints of the conjugate axis. By finding these points, it's going to allow me to create that box that I can use to get the shape of the hyperbola. So to do that, I'm going to add and subtract 12 from the x values of the center. So for adding 12, that gives me 17 comma negative 1, and when I subtract 12, that gives me negative 7, negative 1. And now let me plot these 2 points. So once the points are plotted, I'm going to create a box. I'm going to draw it as a dotted line, connecting the vertices and the 2 points that I just found. At this point, I'm going to draw my asymptotes. The asymptotes are going to go through the center and the corner of the boxes you just created. You can also double check that you have the right asymptotes by using your equation here and making sure that you have a slope of 4 over 3 in this case. And once you do that, now you can actually graph the hyperbola. So the hyperbola is going to go through each vertex, and it's going to get closer and closer to those asymptotes. So if I draw that, I get something that looks like this. And that's our final answer.